All right, class, welcome to this part two on trigonometric functions and acute angles. So we're going to go ahead and continue our discussion of trig functions, and specifically, we're going to be talking about how to find missing sides for special right triangles. Okay, so that's our first topic for the day. We're going to be talking about these special right triangles. So what are they? So there are two special right triangles that we're going to be discussing. It's the first one is going to be the 45, 45, 90 triangle. So go ahead and label that on here. So this is the 45, 45 triangle. All right, and then the next one is going to be the 30, 60, 90, or the 60, 30, 90 triangle. Doesn't really matter. All right, so these are the two special triangles. So what you need to know is how to determine the sides, okay, or the formula for the sides of any of these triangles. Okay, so for the 45, 45, 90 triangle, it's essential that you know that these two sides are always going to be identical, okay? So those two sides are going to be the same length. That's because they both have the same angle opposite of them, 45 and 45. So we're going to call that side A, okay? So whatever that side is, we'll call it A. So if one of the sides is A, that means the other side has to be A as well. So if one of the sides is 5, the other one is 5. Okay? Now, once you know those two sides, it's pretty straightforward. To find the hypotenuse, you take the side length and you multiply by the square root of 2. All right? And that's how you get your three sides. Now, if you're given the third side, then you can use the third side to find the other sides as well. All right, so that's the 45, 45, 90 triangle. For the 30, 60, 90 triangle, the way I remember it is the side with the 60 degrees, the side next to the 60 degrees, has the A. Okay, so the side that is beside the 60 degrees or adjacent to the 60 degrees, that is not the hypotenuse, is A. The hypotenuse is always double that side. Okay, so in this case, the hypotenuse is double that side that is next to the 60 degrees. And then for the 30-degree side, that side has a 3 in it, and it's a very specific number. It's the square root of 3. Okay, so for the 30 degrees, it's going to be the side length times the square root of 3. So the way I remember this is that 3 goes with 3. So I know that the square root of 3 number goes beside the 30 degrees. So every time I see a 30 degrees right next to it, I'm automatically going to put a square root of 3. All right, so these sides are always going to be the same for any type of triangle that is a 30, 60, 90 triangle or 45, 45, 90 triangle. All right, so now that we discussed those two special right triangles, we're going to go ahead and find some missing sides and very specific examples. So looking at this first example, part A in this triangle, notice that that for this triangle, the two sides are identical. So this means since the two sides are identical, this means that this is a 45, 45, 90 triangle. And you could tell this right off the bat. Okay, so this is going to be, oops, apologize for that hiccup there. So you have 45, 45, 90. So now we know that the side lengths are the same, right? So I'm going to go ahead and, call them A, right? We're going to need to find out what A is. Now remember that from the illustration above, that the hypotenuse is equal to a square root of 2, right? So I'm going to go ahead and set that 5 equal to a square root of 2. So I know that this 5 is equal to a square root of 2. So I'm going to go ahead and solve that equation for a, okay? So I'm going to write that down here. 5 equals a square root of 2. And then I'm going to solve for a, so I got to divide off the square root of 2 on both sides. All right, so now the square root of 2 cancels, and I got my a. So I know now that a is 5 square root of 2. So that means that these two sides have to be 5 over square root of 2. However, what I want to do is, before I actually do this, I want to actually rationalize this, because remember that we don't like having radicals on the bottom. So I'm going to go ahead and rewrite it over here. So a is 5 over square root of 2. Now, if I want to get rid of the square root, remember, I got to multiply by the square root top and bottom, okay? So I'm going to multiply top and bottom by square root of 2. All right, and so now that I do that, what I have to do is I know that square root of 2 times square root of 2 is square root of 4, and then the square root of 4 is 2. Okay, so this is going to be 5 square root of 2 over square root of 4, but we know that square root of 4 is 2, so we get 5 square root of 2 over 2. So that's my A, that's my side. So my sides are 5 square root of 2 over 2 each. All right, so those are my other two sides for the right triangle. Now let's look at part B. All right, so for part B, for this right triangle, we know the hypotenuse, just like we did before. We know one of the angles. So automatically, if we know that that angle is 60, that means the other angle has to be a 30-degree angle, okay? So I'm just going to go ahead and label this 30 degrees right off the bat. Remember that the side with the 60 degrees has the A, and the side with the 30 degrees, it has the square root of 3 in it. Okay, so we know that this is the A, and we know that this is the one with the square root of 3. So I'm going to go ahead and write that out. So now I know those two sides, or the formula for those two sides. Remember that the hypotenuse is always double the shorter side, and the shorter side is the A side, the 60-degree side. Okay? All right, so now we know that 4 is equal to 2A. So now we really know what A is. A is really 2, right? So I'm going to go ahead and show this work off to the side here. So we know that 2A equals 4. So we're going to go ahead and divide by 2 on both sides here. And in that case, I get A equals 2. So now we know that A is 2. I'm going to go ahead and label this side. This side is equal to 2. All right. Now since we know A is 2, we also know the third side. So this side is equal to 2 square root of 3. All right, so we know our three sides. Pretty straightforward. All right, so let's look at our next example. Part C. This is another 30, 60, 90 triangle, right? So I know that this is going to be 30 degrees. Remember that the side with the 60 is the side that is A, right? The side next to 60. The side next to the 30 has the 3 in it, right? So 3 goes with 3. So this side right here, with beside the 30, is A square root of 3. And this side beside the 60 is A. As long as it's not the hypotenuse, it's A. And then the hypotenuse is double A, right? So 2A. All right, so now we know the formula for the sides. We're going to use this equation, the 2 equals A squared root of 3, to solve. All right, so we have 2. I'm going to actually write it out the other way. So A square root of 3 equals 2. Now I'm going to go ahead and divide off the square root of 3 on both sides because I want to solve for A here. All right, so we know now A is equal to 2 over square root of 3. Now the only problem here is that we need to get rid of the radical on the bottom. Let me go ahead and erase this again because it's having a little glitch here. So we need to get rid of the radical on the bottom, so we need to multiply by the same radical on both sides. So I'm going to multiply this by the same radical, top and bottom. So now I have 2 square root of 3 over, and then 3 times 3 is 9, and then the square root of 9 is 3. So this is going to give us 3. All right, so now we know one of the sides is 2 square root of 3 over 3. And we also know the other side, right? The other side is 2 times that. So we know that the 2a side, I'll just go ahead and point to it. So this is for the 2a side, okay? So the 2a side is 2 times 2 square root of 3 over 3. And all we got to do is just multiply the 2 times 2, right? So here, multiply those together. 2 times 2 is 4, right? You could put this over 1, and then 1 times 3 is 3. So we have 4 square root of 3 over 3. All right, so we know all three sides. We know the one of the sides is 2, the other side is 2 square root of 3 over 3, and then the other side is 4 square root of 3 over 3. let's look at the last example here for the right triangle. So we have another 45, 45, 90 triangle. If this is 45, the other one's 45 automatically. All right, so now remember that these two sides across from the 45-degree angle are always the same. So I know if one of the sides is 6, the other one also has to be 6. Okay, so automatically this is going to be 6 because remember that both of them are equal to A. So they're both equal to A, and then the hypotenuse is equal to A times square root of 2, right? So that's one of the formulas. So this is A square root of 2. But we know that A is 6, right? So really, this is just going to be A 6 square root of 2. So the hypotenuse here is 6 square root of 2. All right, and that's it for that triangle. It's very simple. It's nothing too crazy. All right, so now we know how to find the missing side if we're given a specific type of triangle. So now we're going to use this knowledge to help us find the trig ratios. So we need to find sine, cosine, tangent, cosecant, secant, and then cotangent. So the 6 trig functions from the previous lesson, or part 1. All right, so we want to be able to evaluate trig functions for trig ratios for special triangles. So given the right triangles below, write the 6 trig functions ratios for the given angle with measure theta. So looking at part A here, we know that this is a 30, 60, 90 triangle. Let me undo that real quick. There you go. So 60 degrees. So now we know since, remember that this is equal to A, the side with the 60 degrees, the side beside the 60 degrees is A. The side with the 30, 3 goes with 3. So this is actually A square root of 3, but we know that A is 3, right? So really we can replace this with 3 square root of 3. So I'm going to go ahead and do that now just to save some time. And the hypotenuse, remember, is 2A, right? 2 times A. So this is 2A, and which is really 2 times 3. So 2 times 3 is 6, right? So I'm going to go ahead and just call that 6. So now we know all the sides. All right, so now that we know all the sides, we can go ahead and find the sine, cosine, and tangent. Remember that for this, we need to use SOHCAHTOA. So remember, SOHCAHTOA. All right, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then to find the other ones, we just take the reciprocal to get them. All right, so what we're going to do, we know that sine is O over H, right? Opposite over hypotenuse. And the so we're going to do, I didn't really specify the angle we need to do this for. So let's just say that the theta is equal to 30 degrees, the original angle that they gave us, okay? So we'll call this angle theta right here. Usually they'll specify which theta they're talking about, okay? So we're interested in the 30-degree side here. So really this should say sine of 30 degrees. So just go ahead and make that correction. This is cosine of 30 degrees. And so on, okay? I'm going to go ahead and correct those now. Okay, and then for the example in part B, we're interested in the theta being equal to the 45-degree angle. So I'm going to change those to 45 degrees real quick. Sorry about that typo there. All right, one more, a couple more. All right, so now let's go ahead and find sine of 30. So opposite over hypotenuse. So the opposite to the 30-degree angle is the 3 side. So I'm going to go ahead and label that. This is my opposite. This is my adjacent. Remember, the adjacent is next to the angle, but it's not the hypotenuse. And then this is my hypotenuse, okay? So now we're going to go ahead and write that out. Opposite over hypotenuse, so 3 over 6. And we know that 3 over 6 is a half, so I'm just going to call this 1/2. All right? Cosine of 30 is going to be adjacent over hypotenuse. And adjacent is 3 square root of 3. And then hypotenuse is 6. And I know that 3 divided by, if I reduce this, that becomes 1 over 2, right? So I'm just going to go ahead and reduce that by dividing by 3 top and bottom. And that'll give me square root of 3 over 2. All right, that's it for cosine of 30 degrees. Tangent of 30 degrees, tangent is opposite over adjacent. That's the TOA part. Opposite is 3. Adjacent is 3 square root of 3. All right, so now first off, I know that we can cancel out the 3's. So if we cancel out the 3's, we get 1 over square root of 3. All right, and then generally we want to rationalize the denominator. So we want to get rid of the radical. So we're going to multiply by square root of 3, top and bottom. And that gives us a final answer of square root of 3 over 3, because we know 3 times 3 is 9. Square root of 9 is 3. So this is going to be square root of 3 over 3. So that's the final answer for tangent. Now for cosecant, cosecant, you just got to flip sign, okay? So cosecant is the flip of sine. So we're going to flip that. We get 2 over 1, which is just going to be 2. Secant is the flip of cosine. So that's going to be, what we're going to do is we're going to flip the, square root of 3 over 2. That'll give us 2 over square root of 3. But then again, I got to rationalize that. So I'm going to multiply by square root of 3 top and bottom. I should have done that in red. And that'll give me 2 square root of 3 over 3. And then last one, we got cotangent. Cotangent of, we got to flip the tangent to get cotangent. So that's going to give us square root of 3 over 1. And what I did is I just flipped this one. I flipped the 1 over square root of 3 and then made it square root of 3 over 1. That way I didn't have to rationalize. Okay, and then this is going to give me square root of 3. All right, so that's the trig functions, the 6 trig functions for that. Let's go ahead and do the last one real quick. So this is a 45, 45, 90 triangle. We know that these two sides are equal to a. Remember that this side is a square root of 2. So if I want to solve that, let me do that off to the side. I have a square root of 2 equals 3. So I need to divide by square root of 2 on both sides. And so I got a is 3 square root of 2 over 2. I went ahead and rationalized there. Sorry about that. If I skip that step, it's just because I do it automatically in my mind. But that's how you do that. You just got to rationalize. All right, so that's my a. So now we know what the two sides are. So I'm going to go ahead and write those out. All right, so now we know our sides. So remember, sine of 45 is opposite over hypotenuse. So let's label our opposite and all that stuff. So we want opposite of this 45 degree. So this is opposite. This is right next to it. So that's adjacent. And then obviously the longest side is hypotenuse. Hypotenuse is always the longest side. All right, so we know it's opposite over hypotenuse. So that means it's going to be 3 square root of 2 over 2 over hypotenuse. And the hypotenuse is, in this case, the hypotenuse is 3. And so what happens here is that the 3's cancel, leaving us with just square root of 2 over 2. So that's it. We get square root of 2 over 2. All right, cosine. Again, cosine is going to be the exact same thing. It's going to be adjacent over hypotenuse, but both sides are the same. So it's not going to change the answer. Forgot the square root of 2 there. And then the 3's cancel, leaving us with square root of 2 over 2. All right, and then tangent is going to be opposite over adjacent. So the opposite side is the 3 square root of 2 over 2. The adjacent side is the same thing. So basically we have two things divided by the same thing. So 3 square root of 2 over 2 divided by 3 square root of 2 over 2. And basically they all cancel out because of the same thing. So basically you're left with just 1. All right. And then cosecant, remember you just got to flip sign, okay, to get cosecant. So we got to flip square root of 2 over 2. And if we did that, we get we get 2 over square root of 2. And then we got to rationalize it. So I'm going to multiply by square root of 2 over 2 on top and bottom. We got 2 square root of 2 over 2. Because square root of 2 is, square root of 4 is 2. And then, so that just becomes 2 there. The 2's cancel, leaving us with square root of 2. All right. Secant is going to be the exact same thing because cosine is the same as sine in this example. And then cotangent, it's just going to be flipping tangent. But we know that tangent is 1. So when you flip 1, you still get 1. All right, so you get 1. And that's how you do trig ratios of special right triangles. That is it for the lesson, guys. I try to keep it as quick as possible. I hope you learned something, and I'll see you in the next one.